I had a sort of basic idea what I wanted to do, but I haven't done any work on it whatsoever. So what I wanted to do was take what we learnt in the last stream and understand completely what we can do, yeah, before we move on. Yes, we're going to convert Myriad to the X16. I've already made that decision. I've already started it, to be honest. But what I wanted to do is completely understand. Right, we've got 4 examples here, yeah? So these are from episode 1. So we've got Hello World. There you go. We have, I think this was Andy's. H's. There we go.
Quality code there.
Yeah, definitely. And then we had we altered the color one. And then I can't remember what this one was. What was this one? Oh, we started messing around with Petsky colours, didn't we? And then we created our very first game, which is Snake, which I cannot play, but it works. Oh, I'm doing better today. Huh.
2 on target.
3, there's 3. 4. Ooh. Oh, come on, John. You can do better than that.
Andy, you haven't tried Drunken.
Drunk Snake.
I was doing... Oh, there we go. There we go. Anyway, I've had enough of that. It's not Halo.
Microsoft shit.
Say again.
Like Halo for the X16.
Halo for the X16. Oh, I'm sure Microsoft would have something to say about that.
Fuck Microsoft.
So, what after I'd done Snake, I thought because I haven't even set up the GitHub. That's how distracted I've been with Halo. I wanted to understand the complete dimensions of the screen, right? Because this documentation
by 64, there's 64 by 64 on the screen.
So not very good, is it?
101 lose you
hey,
gain
Face.
speed on
Welcome.
the glitter by cutting.
Yeah, the documentation has a lot to be desired. A lot to be desired. I mean, you know, well, I'm saying, I seem to be bashing him again, saying that his vision was to have a book that you could use to learn to program it like the VIC-20 and the Commodore 64. This ain't it.
Mate, Dave hasn't done any of this. This is all been done by the community with him as a figurehead.
Yeah. Well, it's sort of letting it down, isn't it?
It is, massively. And especially as they changed it all just before release.
Yeah.
It's shit, which is why I've started documenting a lot of the stuff for us, not for anybody else.
Right.
Although it's going to end up on my blog at some point.
Yeah, I mean, that's the best way of doing it, mate. So, I want to understand the limitations of the screen, because apparently, if my understanding was correct last week, right, is that is a viewport to the bigger screen area.
Correct, Amundo.
Now, what I was going to try and do was try and write a small program that allowed us to scroll around to find the limits, yeah? Because I think this Saucy in. Is Saucy in here?
Yeah, I'm here.
Hey, mate. I think Saucy said it was 120 wide.
28.
1, 2, 3, 4, 5. 128. Because, yeah.
Each row is 128 characters and 128 colour bytes, so 256 bytes to a row.
Yeah.
Yeah.
But what I watched, do you know where we was doing the scrolly thing? We did some manual scrolling, didn't we? Hang on, let me close that down. We did some manual scrolly stuff.
That's in pixels, though, not characters.
Yes. That's what I was thinking of doing, was just creating a simple example with 4 keys, WASD, that allowed us to pixel scroll across the screen and see how far we could go. Yeah. Just to try and understand the limits of how far we can do. If we was going to do, say, a pixel scroller game, how far we could go before we have to do the character wrap or something like that, or what we could get away with. All these numbers that you mention, you can write on the screen. What numbers? Yeah, well, I know we need a X16 programmer's guide, mate. This is. There
isn't one. That's
there isn't one. This is. I don't know. I don't know. I mean, this attempt. Yeah, it's an attempt, but not a very good one. I mean, I was expecting a diagram with a, picture in, viewport area, that sort of jig, but nah. So we're going to have to learn how to do it ourselves, and Andy says he's going to document it for his blog, which will be very welcome.
If I ever sober up.
You're not writing the programmer's reference guide then, John.
Oh, come on, mate. I ain't even done that other book. I'm waiting for people to tell me if it's written wrong. That book is being sent out for proofreading. I've not heard anything except from Derek. Still reading the other book. Oh, which other book? My book. As in the beginner's book. Yeah. So, a programmer's reference. I mean, we could take a version of the 64 programmer's reference guide and just change the bits that we need to change. Anyway,
there's a bit more to it than that.
Oh, I know it's a bit more. I know, but it's just a way of getting across my frustration at the pushing of this and then the lack of documentation that goes with it. Anyway, so
there's a few good websites and there's a few good YouTube videos, but the problem with the YouTube stuff is it's out of date.
Yeah,
so all the pointers are wrong.
Yeah, because when I was looking, when I should have been working, when I was looking, the interesting ones were older than the update. So yeah, it was a bit annoying. So we're gonna try and explore the character screen today and see how far we see how much we can do in it, because the snake thing was great in converting it to make it work, but I still not sure how it works. For some reason it just baffles me how this works. So yeah. So we're gonna utilize their read routine. We'll utilize this read routine, which is doing the character in. I thought they would have done a 197. Well, is 197 still a thing? Obviously not.
Hi, John here. Another subscriber. Stay a while.
Don't forget, this
Forever.
is kind of based on the Commodore kernel, but it's not the Commodore kernel.
Yeah. That's why they're probably using... Hey, Mikroman, welcome in. 40 months. Jeez. 40 months. That's a long time. What's the escape key? Well, it's definitely not that one.
Control C.
Click what?
Control C.
Control 3.
C.
Oh. Why Control C when we've got a perfectly good escape button on the keyboard?
Cheers, Andy. I was waiting ages to find that.
Because it's 2012 mode, isn't it? It's 2024.
Right, so 197 doesn't work. So, and I bet you this memory map is pants.
Yes, it is. And that's being very polite about it.
Hi, John here. Another subscriber. Stay a while.
Hey,
Stay
Saucy.
forever.
Thank you for the subscription, mate. 21 months on a 7-month streak. Nice.
I need to get a drink that's got not got alcohol in it. Be right back.
All right then. he's gonna get absolutely wasted, isn't he?
No, I'm not. Yes, I am.
Hey, doesn't it make a change that the presenter doesn't get wasted, but one of the audience does? Exactly, Stack. Exactly. Right. So, we don't even know what the memory map is, which is just... So there's no way in knowing.
Look, I hate my job, and I'm trying to cope with it. Okay, alcohol's the only thing I can do.
Yeah, that dude, do what you need to. I am not going to tell you otherwise.
Well, I could just quit. That's what I usually do. But I found a bottle of wine in the bedroom, so I thought I'd drink it.
Right, let's see.
You're lucky because my wife had a glass. Otherwise, I'd be really fucked.
Right.
Okay. Not even French, Anglo-Saxon.
Hey, Proton. Hey,
For those
Proton.
interested, I'm now drinking milk.
You're now drinking. Oh,
With
on all
alcohol.
that acid in your stomach from the wine.
So the milk
With the Baileys in it.
cancel it out.
Won't it curdle?
I've joined you. I've got a wine now.
Bird, Dr. Feelgood, milk and alcohol.
Ugh.
I like milk. What can I say?
I'm just searching for the forums, see if there's anything about memory maps, but...
I have looked, mate. It's like fucking hot shit.
Right.
Oh, looking at...
I mean, look, it says the memory map is identical to all revisions of the C64. When was this written in? February 2024?
All revisions. So all revisions had exactly the same memory map.
Yeah. And this was what?
No.
24 days ago? That is false because we've just done a 197.
It may be talking about the function calls, not necessarily the variables used by them.
Yeah, I was looking at the spec for the Vera and how things work, John, the other day. And thinking about if you wanted to do a horizontal scroller, you can scroll so far with the registers that shifts.
Yeah.
But then you're going to have to actually write a whole new line in because there's no way to copy a line. You know how on a 64 you'd copy the bytes across.
Yeah.
You can't do that. You've got to write it again.
No, you can. You can use data 0 and data 1 copy from data 0 to data 1 and have two sets of registers in the memory map, in the memory pointer. So you can do it, but you do have to write the entire line. So, but you've got 128 characters, and if you put it into 40 character mode, that's quite a lot of copying a lot of scrolling you can do.
Yeah, you can do quite a lot, but at some point you're going to have to rewrite the entire line of data in. How do you copy from 0 to 1? I didn't see any way of doing that.
So you set up the memory pointer to point to the source using data 0, and then you set the same variables up again for the read, for the write area, sorry, in data 1, and then you read from 0 right to 1.
So there's there's two memory addresses then.
Yes, you see the top three variables you've got there. If you set the data bit, which I can't see because I'm too pissed to see what I'm doing, but you can set one of those to be data 0 and one to be data 1. So you read from 0 right to 1, and then it increments them as you go along.
Yeah, I'm with you. So it does the copy, because you can select whether you... Yeah, I'm with you now.
Yeah.
Because your address select, you've got 0 and 1, so you can put an address in for VRAM low and high, etc. 1.
Yes.
And 0, and then
Yes.
to shift. But it's still quite a long-winded process.
Yes.
Not as quick as copying 40 bytes, one space across in a 64, I wouldn't have thought.
No.
So,
but then what you can also do is you can have 128 bytes across and have a screen, and then you can below that in memory you can have a second screen, a third screen, and a fourth screen.
Yeah.
Then all you do is you change the screen pointer to point to the second set of data, so you can effectively have a much bigger screen buffer.
Yeah.
Or have two screen buffers and be updating one while you're scrolling the other one.
Makes sense. Yep.
Similar to the way we did it with Hunchback, but different.
So let me understand this, right? This bit is the driving force of doing that copy, what you were saying, yeah?
Yes.
So you would set it to 0 and then set these to where you want to read, which then puts in data 0, yeah?
Yes. I've
Then
got lag
set
on the
that
screen,
to
so I can't
1.
read it.
Then set that to 1, change the address, which would then you would have to store. That's where you would store it, yeah?
Yes.
So when you do a read, does it auto increment?
Yes.
Yeah. By address increment on 9F22.
So right. So let me. I'll tell you what. Let's just do it, shall we?
So you've got 4 bits for your address increment. So you've got up to 15.
Yeah.
I don't know whether it counts 0. I'm sure I saw something about 0 is 1.
Right.
No, 0
Up to 16.
I can't remember off the top of my head.
Right.
Yeah, I'm sure if you
let's
set increment to 0, it increments by 1. I'm sure I saw something about that.
let's have a crack. Yeah.
I think 0 is 0 and 1 is 1. Then it's 1, 2, 4, 8, 16, 32, 64.
Ah, yes, that was it. Yeah.
1 to 8.
Table.
And then once you get to 1 to 8, it goes in different increments because of the screen size.
Yeah, it was like 40 and 80 and so on as well.
Yeah.
I remember now, yes.
That's it.
Welcome, Raiders. Gaz, welcome. Hello. Right. So I'm going to take this example, yeah? So we're going to use example 2, and we're going to try and see if we can copy line by line, yeah?
Yep.
So we should be able to, once we've stored the first line, we should be able to set the addresses of both, yeah? So we'll do a read address of where we've just stored, yeah? and then do a write address, say 2-3 lines down or something like that, yeah?
Yeah.
And then just do a load and store 80 times.
Yes.
That's how, what you've just said, that's how I'm understanding it.
Yes. You'll have to reset 0 though, because 0 will have incremented beyond the end of the H's.
I need to reset what?
So you're going to write 40 H's on the screen, aren't you? In that loop.
Yeah,
And then you want to copy them to the second line, yeah?
yeah.
So you have to reset 0, data 0, because it will have moved on. And then you have to set data 1 to be 128 bytes. No, 256 bytes.
Bytes further on.
Further on, yeah.
Right. So this is what we're going to try and do, yeah? So this is set it right. So this is so that's the setting up the line of H's, and then here, right, we are going to copy that line elsewhere. Right?
Yeah.
So I am going to do this, and then we're going to modify it. Right. So we need to set. Right. Let me try and remember. So control is irrelevant. The address is going to be the same. Increment. That's how 1 by 2. And direction. What was direction?
It goes backwards or forwards. So it's a -1 instead of 1.
So what's
So
control? Okay.
that's the same, and then you do it again, but with control as 1.
It's control, isn't it?
Yeah, because control sets the data byte as to which register it looks at.
Right. So it's the control we need to change.
Yeah.
So if we reset that for 0 and then do that and 250, no, let's do it 200 further on. So that's setting the address for data 0, yeah?
Yep.
And that's setting the address for data 1.
Yep.
Right,
That might
so
not be, yeah, on the screen.
then,
That'll be 2 lines further down.
Yeah, that's fine. Should be okay.
so here we're saying data, we're going to load data 0,
Yep.
and then we're going to store it in 1.
Yes.
So
And that's it.
Yep.
that looks about right.
I think so.
So if we run this, well, I never.
Did it work?
Yeah.
There you go. Sorry, I'm way too drunk. I've got way too much lag.
It did work. It did work. I am not sure what these artifacts are here, though.
Interesting.
Right. So let me.
You've only done 80, which is only 40 characters, isn't it?
Yeah. So
Yeah.
let me. This is the original. Let's just make sure it's not on the original. So it's not on the original, right? So
Don't think he's on the original.
So if I go on to this one, so we run that again. So that has, yeah, it's done this.
That makes no sense.
Let's look at the code again. Make sure there's no garbage in the code.
Well, what I'm going to do is I'm going to rem out this, right? So we don't do the copy. We're just setting the registers, yeah. Right. So setting the registers are fine. Now, is it resetting the register?
Should be okay. I don't see.
Right, let's look at the byte dump. All right. So this
Just do a F12 on the actual window. Gets you into the monitor mode.
right. Okay. So let's put this back in then. Now he said that we should be able to double hit the PC, yeah?
Yeah.
Oh no, it's here down. Was it set or something?
R PC space R space PC space. Is it 80D?
Yeah, hang on. I'm just about to find out. Byte dump. Oh,
Yeah.
can't even paste it in.
80D.
Right.
What do you expect? It's a 1980s machine. Of course, it's not been invented yet.
So it's F10?
F10, I think, yeah.
Right.
F11 steps over.
So what does F10 do? Step in?
F10 runs the next command. F10 jumps over subroutines. It runs the entire subroutine until it returns.
Because it went to 03 something, didn't it? So that's doing the H's, yeah?
Yeah.
22, 21, 10, here we go, 8, 4, 3, 2, 1. Right, here we go. So now...
Prepare screen before you do that.
Yeah, I know, mate, I know. But I don't know how you... Oh, I could have...
Yeah, I know.
Yeah. Anyway. So we're now setting... So we're now doing... this. We're now doing that. So that's setting the address for data zero, yeah?
Yep.
So we loaded that control byte in, which was 0. We and it with FE. Oh, hang on.
You might want to check those macros because those macros are written.
Well, one, it should have been a hash.
Yeah, that'll do it, mate.
That's what I spotted.
You added, I want to point out.
That's what I spotted. Right, let's do it again. Let's
yeah.
several open as well. Right, let's do it again. Right, is it CLS? Oh.
Yeah, CLS works.
That's where ready is. Look.
Yeah, it's got confused over where its cursor and everything is, isn't it?
Yeah, we've screwed it up. So that's ready.
That's probably because we're not restoring and saving any of the registers between the machine language and the interpreter.
Yeah, so if I do this and then run it, there you go. So that's where those artifacts came from.
Yeah.
So that's a bit stupid that when you come back to basic, Vera's all thrown a fit.
Yeah, but that's because I didn't save anything in that demo program, mate. That was just some cheap, quick and dirty shit I was putting together.
Yeah, but they don't say anything about that, though, do they?
You would have thought when you went back to basic, it would set its VRAM registers to where it needs to be.
Yeah.
Tell you what, John, try reading 9F20, 21, 22 and storing them somewhere, then putting them back when you've finished.
Also, John, change those 79s to 80s and see what happens.
Sorry, say that again.
Change the 79s to 80s in my code, that demo code I did. And you may see that it's right into the right space on screen.
Right. The jumps, so I've left the jump in there, so I'll take that out. You'd think.
So it's this way
You're
now.
pointing at colour memory instead of character memory.
Yeah.
I think you need to reset Vera registers 2021-22.
Or do a reset on the Vera. There's a register that lets you do a reset.
Yeah.
Oh, hang on then. Let's try the easy one first. So it's this one, yeah? That's to set that to 1, yeah?
Yeah.
Right. So let's
$1.80.
Yeah, so let's go in here. Right, so do that. So our reset is was it the control? Oh. Yeah,
You don't
so
need the
that's the
parameters.
control address, isn't it? Right.
Yeah.
So we are basically going to go LDA control. No. LDA that. In fact, if we're resetting it, who cares?
Yeah, it's exactly just set it to 80 and then just
Yeah.
give me the rest of that code.
Who cares? Right, so we just set the Vera that like that. Yeah?
No, it's 80, mate. It's a high byte, so it's $1.80.
Oh, is it that way round? Yeah, okay. Right, so
No, you need $1
yeah.
or two.
Right then.
No, you need $1, mate. You need to change that $1 first. Bingo.
Yeah,
Let's go for it.
here we go. We reset the Vera.
That resets the display. Yeah, I think you're better off loading those values and putting them back.
Yeah.
Yeah. Well, at least we've got the reset Vera in there. So,
I think you might need a macro save Vera and restore Vera or something.
Although at the end of the day, who cares about the game? You're going to reset the game to restore the machine, so bugger it.
Within a game, yeah. You
yeah,
don't
within the
care.
game, you would probably never go back to basic, but
You never stop playing because it's such a great game.
well, this is it. But seeing as that we haven't written a game yet, hang on, let's just see.
John's going to set up a repository for it later. He said he forgot. Because he's ignoring chat because no one's in chat.
Say again. Oh,
You're ignoring text chat. Prince put about
Prince.
last
Yeah, I
week.
haven't set up the git. Sorry, I ain't set up the git. Hey, Dr. Mortal, welcome. Probably just the control bit to select data set to 0 before returning.
No,
Oh.
because it's writing the characters in where pointer 0 would be at the end of the line. So after you finish your copying, data 0 is going to be pointing where it says ready in it.
Yeah,
But it doesn't need to be there. It wants to be down where.
where we were
Running.
before. Yeah.
So I think you need to save those, at least them 3 registers.
So how are we going to do that in macro form?
With a load and a store statement.
Yeah, but where we're going to store it, that's what I'm thinking.
You need some temporary variables.
Yeah.
Or push them on the stack. But that's a bit dangerous.
Yeah. What's everybody going? I've got Twitch up now, so I can see it. I am going to complain to Twitch Authority. I want Twitch to stop the presenters just interacting with the audience on Discord. I didn't have the chat up. Sorry, I've got so many windows open.
Prince, just get your ass on Twitch, on Discord. God, man.
Right.
This is
I've been a noob.
Twitch chat is very, very much one way. Discord's interactive.
Yeah, and you can swear.
And you can swear.
You can say what you want, it's not even filtered. I can make racist comments.
I could close all those windows. Yeah. Right. Okay. So you're saying we need to store all of these? Yeah, these three.
Yeah, I think just them first three should be all it needs, and then restore them.
Right, okay.
When are you going to save them?
Right. So let's do this then. Oh.
Prince, it's always possible to go on Discord. I've got it on my phone. I've got a dog on my knee whining at me.
Right. So, let's do this. Dot macro. Backup. Right, so load that, store there, that, if that will do that. So what's the other one? Low, high, I suppose it's this bank, is it?
No, there should be low, mid, and high.
Yeah, it's bank. Yeah, it's bank.
No, it's low, high, and bank.
Yeah.
Okay. That's not what they're called on the other page.
I know. Right, so we do that, and then we'll do an exact copy of this to do a restore.
I'm not sure if you can, because that register is used to set both banks up, or both pointers up. So I'm not sure.
There must be a way of setting it and restoring it, though, to where you were.
Yeah, I'm just wondering if you need to set the select bit first, then read it.
What have I done wrong there?
Yeah, probably. Yeah, you're probably going to need to do control as well.
Yeah.
And
Control first.
Yeah, like Andy says, do control first. Read control first, and save it, and then read control first when you're putting stuff back.
You don't need to read control. You set control. Oh.
Yeah, but you don't know what it is.
But if you want to save pointed 0, you have to set it to 0, read it, store it, and then read 1. Or set it to 1, read it, and store it. And also it's a bit, so you're gonna have to do some Boolean maths on that, mate. You're gonna have to and it or it, an exclusive or it.
Yeah, well, I can worry about that when we do the restore.
It doesn't say whether they're read-only or not, does it? Right. So I'm thinking if you read control, that's where it currently is set to. So if you put it back at that, yeah. The trouble is we don't know if we're changing bank 1 as address 1 as well as, and don't know what. Yeah, see what it does, John. It's a bit confusing this now.
Yeah. Well, this is why we're doing it. Yeah. So before we do anything, backup veer info.
I think we don't care because it's a game and we're just going to blow it away anyway.
I know, but oops.
Yeah, but what if we want to write something that's basic with bits of machine code?
Because we're hardcore when we write machine code.
Oh, did
yeah, but John's doing this.
Call it a different name. Yeah.
Thing is, if we weren't doing it hardcore, we'd be using the kernel routines. So
we'd be all right using the kernel routines, mate, if we had a memory map that told us those kernel routines existed.
Don't be logical.
Until such time. Right, let's see if this does what we think it does. Well, would you believe it?
Nope.
I would. Because that's up, Docster. It makes sense. The only thing is you probably should back up address 1 as well, but it most likely doesn't use it.
Hey, Docster. Welcome in. So, right. So, we've managed to copy. So let's just emphasize this a little bit more. So let's put it at 6. Make it big. There you go. Now that's I like that. You set the address. You don't have to worry about reading the next character. Just tell it to read store, read store, read store, read store. Don't have to worrying about changing addresses and stuff like that. Now that I like that. It's a bit to get your head round it.
Yeah, exactly. But for like scrolling a line left, all you're going to do is point to byte 1 and byte 0 and read from read and store, and it'll move everything across 1.
Yeah.
To left. If you want to go right, you're going to have to start at the other end. Then it gets a bit awkward.
Yeah.
But then that's where you've got your -1 on your step. Direction, whatever you call it.
What, the address increment? Yeah. Because I mean, they've got the
we
address.
don't have to scroll right, we scroll left.
Yeah. I mean, they've got the address increment, but it's only 4 bits.
Yeah, and there's a table, like Andy said earlier.
Right.
0 is 0,
right
1 is 1,
yeah.
2 is 2, 3 is 4, and so on. It goes up in powers.
Yeah. Goes 5, 1, 2, and then goes back to 40, and then goes 40, 80, 160, 32, 1640. Setting the deck bit will decrement instead of increment. Oh, is there a deck bit?
Yeah, last plate.
So it goes backwards, not forwards.
Oh, right, okay, I see it now.
So if you want to shift stuff to the right.
Hey, Skim, welcome. So, what have we learnt in this exercise? That you can, as long as you set your 2 address lines, because there's only 2, you can load from one data point and store to the other data point without having to worry about modifying an address, remembering your indexing.
Tell you what I've learned: don't drink on a Monday.
There's nothing wrong with drinking on a Monday.
The reason you're not very good at it.
And we've also learned that if you're going to use you want to return back to basic, we've got to back up the Vera and then restore it before you finish. Right, so
Learned about colour, you can do in steps of 2 instead of 1.
Yeah, steps of yes. So this
Which would make it a lot quicker if you didn't need to move your coloured byte as well.
Well, I mean, let's do that. Let's just prove that, yeah. So let's paste that and 5. Right, I've done 205, episode 2. Number 5. Right, so if we do that and then reduce that by half, right? We should copy just the character and not the colour, yeah? Let's see.
You're only gonna...
Yes, look at that. Now I'm getting it. Now I'm getting it. Right. So
I've seen everything that you can write a scroller now, John. Character based anyway.
yeah. So here we go. Right. Episode 1, how to create a scroller in X16. But we don't know how to get to the character map, do we? Oh, just a basic scroller. Yeah, just a basic text scroller. Ooh.
Ooh.
I was just... Oh, right, okay. Okay, let's do a basic text scroller. Right, so this I'm gonna get rid of that. Transfer Y into A. F6 it. Right, so we've got loads of different characters and colours, yeah? So let's do text scroller. Hang on. So you said it was 120 across, yeah?
128.
120. No, that's the full line, but what's the screen? Screen was what? 80?
You can scale the screen though down to 40, 20.
Yeah. But we're just using the default. So that's
160 bytes.
yeah.
Yeah.
116 bytes, yeah?
2 times 80.
Yeah. So to do a very simple text scroller, we need to move everything out, yeah? So if we're going to go that way, well, that way in my eyes, we need to read that one first, store that away, and then set data 1 to be 2 bytes in from data 0, and then just read, and it should do that, yeah. And then right at the very end, take that byte that we've done, and in fact, I'm going to do this in steps of 2. So we're not worrying about colours. Right, so that's just all, yeah, right. And also, let's LDA hash oh, there. Where's clear screen? Yeah. Did we have... No, we haven't put any of the kernels in yet, have we? No. That's alright. Right, so that should clear the screen. No, it shouldn't. Would help to load the constants in. Right, okay. We're on a winner. Stop yawning makes you yawn. Right, so we've just put the characters on. Let's put a... let's do that. So, here... So if we're going to read from 1 and 0 and store in 1, that means that's going to be 0, 2. So we read. So we're going to. Oh no! Hang on. Let me get this right. No, it's that way round, isn't it? Yeah. And. There, that's that. Right, I've put them both the same. You'll see in a minute why. So we're going to load Vera naught, store it away in here. That should have moved it on to. That should have moved that onto 2. Yeah. That should have moved that on to 2. And then we're going to load Vera 0 and put it in 1. Yeah. And then... Right then. Let's see if this moves it. I think. So let's get it to come here. This might be too quick.
Definitely doing something.
Yeah, but it's... Oh, it's because I got that 40, isn't it? Hang on. Yeah, I think that's scrolling it. I think. How are we going to slow this down?
John,
Yeah.
9F26 bit 0.
Nine F26 bit 0. Oh, right.
I don't know exactly how it's whether it's a 1 for, presumably it goes to a 1 and VSync. So maybe wait for it to go for a 1 and then go around again.
Yeah. All right.
Just use the WAI. Use WAI, it waits for the next interrupt.
WAI?
Yep. WAI. Whiskey Alpha Imbecile.
Yeah, but... I don't know what you mean by WAI.
So there's a command, an output code called WAI,
Is
that
there?
pauses until the next interrupt.
Yes, but what is the next interrupt going to be?
By
Is it a line
default,
or a frame or what?
by default, there's only the VBL running.
Right, okay then.
So if I just type in WAI,
That's it. That's perfect. That's genius.
you are joking.
That's
You
provided you
don't need
haven't
to joke
set
about
up.
anything.
Well, that's scrolling.
Yeah. Provided you haven't set any other interrupts up, like for per line positions or line syncs or
Yeah.
anything.
Exactly, but by default on the X16, only the VBL's running.
I don't
I'm
know.
glad somebody knows that, because nothing seems to tell you anything.
I saw that in a video somewhere, mate. I'm just hoping for the best, and what I've seen on the internet's right.
Oh yeah, no, we're all learning because it's all new and documentation's a bit.
You can
weird.
see that scrolling, right?
We
Yeah.
can.
At 60 frames a second.
And we didn't do anything. All we did was change. We added one temporary byte, but it's the same code as the copy.
Yeah.
Don't forget as well, this thing runs at 60 hertz regardless.
Oh, I know about the speed, mate. But what I'm saying is, we've created a scroller
Yeah.
from that copy code.
Yeah.
Well,
That Vera is very, very impressive, mate.
it's right.
It's sexy.
It's getting there. Right. Okay, let's do another one, right? Because we're just doing the characters. So now we're going to do the colours as well, yeah? So I did the colour one here, didn't I? No, not that one. That one. So we used the colour byte there. And we did that.
Andy seems to know what he's on about. In terms of character set, the characters are actually tiled.
bank on that.
aren't
Yeah, they are tiles.
they? So to replace so you can define your own character set just by putting a new tile set in memory.
Yes.
Yeah. Okay.
Yeah, we'll get there eventually.
No, I'm miles. I'm just trying to get it all in my head, John.
Yeah. So we need this in, don't we? To do the colours. So we're setting up. Oh, I've missed. I missed that. In fact, I've put it in the wrong place. It's there. And that is TYA. So I'll get rid of that. Right, so this is now back to 160. So we're going to do every one. Right, so if I run that, that's just going to move the characters and leave the colours intact, which it's doing. Alright.
Yes.
So now, to do it so it does the colours, we change that to 1, that to 1. We need another one of these, but this time it's first colour.
Just use the same loop and double the length of it.
Say again, mate.
If you just use the same loop but double the length of it, it'll copy the color RAM at the same time.
Yeah, but the very first colour that we need to wrap round, we need to take a copy of it, don't we?
Oh, so you're saying, yeah.
And then put the colour at the end.
And do twice as many bytes. Actually, it should be best 2.
No, all
Well,
we've done is
8.
we've just added this and this. If you ignore the setup routine, yeah? And then this goes to 160.
Yeah.
So...
But should that be 160 or should be 158?
Oh, the colours are not copying.
Yeah, change it to 158, John.
Am I putting the colour off one off, am I? No.
No, hold on, go back to your code. What? Why are they both set to 1B000?
Because we're reading data 0 twice, so this would be 1B02. And then we're reading from 1 to 0.
You need data 0 now, don't you? You need to write the data 0 because you're copying the code. You're copying colour now. So you need to start at.
That's the mistake. That's the mistake. I saw the mistake. There you go. My bad.
That too fast to see out on Twitch.
Say again.
Because of compression on Twitch, it's hard to actually see it properly.
What, my code?
No, the scrolling.
Oh, the scrolling. Well,
I'm sure it's right. It's just compression makes it horrible.
Yeah. Well, once I've got the Git, you'll be able to download it and mess around. But look, we've now got a full text with colour scroller.
Not smooth though, is it?
No, it's got a bit of a stutter to it. But I don't know if that's my computer.
No, I mean it's not pixel scrolling; it's character scrolling.
Yeah, but it's so fast. It's so fast. It looks like it's pixel. When I'm looking at it, right, and it looks like it's a smooth scroller, and that's because it's that fast. It does look smooth. It must be just the way the eye perceives things. But it has a bit of a stutter to it, but I'm not too sure if that's my computer running the emulator or not.
It could also be the Twitch compression or the Twitch interpolation.
Yeah. You need to upgrade your glasses. See, what Dr. Wombat spotted the error. I've only just noticed in chat. He spotted the error. Right, so. Right, let's make it better so we're not looking at the top. So if I do this, that should be some way down the screen. There we go. There we go, that's better. So as Saucy said, this is not pixel scrolling.
You need to change it so it says Dixon's is shit.
Say again.
You need to change it so the text says Dixon's is shit. That's what we did in the good old days.
Hang on.
Yeah, but you need the poke in there first. That's not what Andy said.
No, you've got to put shit. That was what we did in the day, and it needs to be caps as well.
Yeah. I'm better than that.
That's fine.
Line 83. Shouldn't that be is? Oh, right. Did I put in? Yeah. Okay. Yeah. Right. So the next thing is to try and explore the surface. Yeah. So here's the Vera. So we want to. We're going to create a routine that's going to read the keyboard, and try and move the screen viewport around. Yeah. To see how much of a screen we do have. Now, we was messing around with that, but I can't remember what byte we were messing around with.
It was the screen 1 XY scroll register. It's near the bottom somewhere, I think.
Oh, right, okay.
It says like scroll in the description. X increment, is that it?
Well,
Scrolling the... Oh, these.
layer 0, H scroll, V scroll. I don't know.
These here.
They look right.
So L0, is that our screen 0, yeah?
Yeah, but it's screen 1. I think screen 1 is the one that's active, isn't it?
Is it screen 1 that's active? So that would be this one here, down here.
I think so. I can't remember, mate.
Well, we'll mess around, yeah?
Just V-poke it.
Yeah. So, now, okay, so let's do that. Oh, can I not reset this?
Reset what?
Reboot the 16.
Yeah, Control R or Control B, I think.
What in it? Okay, hang on.
You got them out of the monitor.
How do you get out of the monitor?
Escape, I think.
Yeah, I'm pressing escape, nothing.
X, Q,
E.
Oh, F12 again.
Control C.
F12. F12.
No, F12 won't do it.
F11, 10, 9, 8.
No, it's not either of those.
No.
I can't remember, mate. I'd have to walk to the other room and get my book.
Let's just load one of the other ones up then.
I have actually got someone's done a PDF on on all the commands for this. I'll post it.
Right, so we was going to poke $9F37. That's the low one. Yeah, comma 0.
Comma 0 won't do anything.
Yeah, okay. 128. Right, so it's definitely 1. Yeah?
There you go.
So how... If 0's not going to do anything, does that mean we can't scroll that way? We can only just scroll that way?
Yeah, your viewport is basically the top left of the window.
Right, so the top left is a 0, 0 in the memory thing, yeah?
Yeah,
that's the impression I get. Yeah.
Right.
Yeah, but you can set your scroll your viewport to anywhere in that block of memory.
Yeah, yeah. But by default, it's in the top corner of the memory, yeah?
Correct, Mundo.
Right. Okay. So let's. So we know we don't need to copy the X and Y because we know just resetting it 0, 0 will put it back to where it came from.
Yes.
Right. Right, let's do something. Let's do something that's
Some
gonna be-
good. It's in basic.
Well, I know that, mate.
Until
The problem is,
Oh,
I
no,
was
go on.
told doing basic it was slow. Because it's like it
Also-
copies and pastes it in or something.
Also, if you change the scroll thing and then do a CLS, it won't clear the viewport. It'll only clear the top left-hand side of the screen. Because Basic doesn't know it's scrolled.
Right. Okay.
So Basic assumes that the screen is the top left-hand, top left-hand corner of the memory.
So we're gonna grab this from Snake. So we'll grab that from Snake. We will
Come here.
do that. So this is going to be number 8. So we don't need that. We'll leave the clip. No, we'll rem that out, and then we'll put it in if we need it. Back up we need. We don't need any of this. And the restore. Right. Right then. So, where's Snake gone? There we go. Copy that.
Also, as far as I'm aware, if you use the kernel routines, it will only draw to that original viewport. It won't draw to the scroll positions because the internal registers aren't set.
All right. Right, let's grab that. And grab
Also,
them.
Dixons don't exist anymore, so it should have been Dixons were shit, not our shit.
Right, so we don't need to worry about current location, current direction. We don't need to worry about that or that or that. That, and don't need that. So going up, do some code. Going down, do some code. Going right, do some code. Going left, do some code. Right. So, character in. So if we're gonna go up, right, let's add some constants because we said we was going to try and do this by adding the constants in. Yeah. So constant, and we'll keep the same labeling going.
I hate underscores.
So
Just saying.
H scroll low. What do you mean? Go away.
Okay.
Not you, man.
Oh, okay.
Not, it's Windows 9F.
Windows is shit, mate. Get a Mac.
Right, so H scroll high is 8.
By the way, you can scroll down to minus 127.
Minus.
Yeah. Was that sprite positions? That might be spare positions.
Yeah.
Ignore that.
Right, so hey, so this is V scroll, and 9 and A. Right, so we've got the horizontal scrolls in there. So if we go back to this, so this is scrolling up. So at the moment I am going to be just messing around with the low value for the moment. So we're going to DEC, VER, Vera, L1, V, low. So we're just going to decrement that value, and then here we'll increment.
Don't forget that's in pixels as well, so you won't get all the way to the end.
Yeah. That I just want to do pixel, mate. That's all I want to do. So left is decrement.
Yeah, what I mean is you won't get to the end of the actual screen because it's more than 100. It's more than 256 pixels. This is 16.
Oh, you mean to scroll full screen? No, I'm not aiming that. I'm just trying to see if we get get some scrolling, mate, and then we'll make it full. Yeah,
it's fine, mate. It's fine. I just want to point it out.
Yeah.
I think it's 9-bit.
Right. So if we read keys, so if I do looper, oh come on, John, get a grip. Right, looper. So we do read keys, read key. So we do the read key. We do that WAI, E, and then jump looper.
I'm not going to test for exit.
I haven't got an exit key in there, but I suppose we could do.
I thought you had. You got up, down, left, right. Oh no, you haven't.
No, I ain't. But I suppose
It
we
was
could
in.
do.
It was in the other bit, wasn't it?
Yeah.
In the snake thing. You did check for exit or start or something.
Yeah. So the exit, we can definitely do that. Because it says no valid key there. Well, let's just scroll it because we're just going to
do it without.
Yeah. Right. So hopefully. Right. So I'm not touching anything. We're not scrolling. That's a good sign. Right. Here we go. So let's see. Right. So that's as far as it'll go because we're only doing the low byte.
The excitement's palpable.
Yeah, but I was going down. So there isn't that many. There isn't that many rows at the bottom, then, is there?
Yeah, because it should go into secondary memory. So it shouldn't. It doesn't just loop round.
What, the memory doesn't just loop round?
The memory does. The memory just carries on going down. So that's just. That's been written. That is different memory you're looking at there.
Is it?
That's a different. Yeah.
Oh. So if I go down, right, that at the bottom is not what's just gone off the top.
I don't think so.
No, because there's extra. I thought there'd be more lines than that at the bottom.
That's what I thought. Now let's put the full.
I don't think it wraps.
Mind you, there's 80. How many lines is there on screen?
Did we say 60 or something? Right, here we go. Right, you ready? You ready to count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 60. 60 lines. Oh, we've got to scroll up. Well, I never. So there's 60 lines down.
It loses though, doesn't it? Does it?
I'm not sure what it's going to be doing when you do that.
Well, it'll probably lose it like scrolling down. Let's have a look. So if I do that and then scroll down. Yeah, it's lost it. Yeah. But the thing that gets me, right, is I was expecting far more lines.
No. How much RAM is per screen? Is it 16K for one screen?
No, I think it's 4K.
So 4K.
8K, sorry, 8K.
No, that's not. If you've got 256 bytes per line and there's 64 lines, because there appears to be 4 lines of garbage at the bottom, that would be 16K.
I'm sure I read somewhere it was 8K.
Yeah, 16K with the 4 lines at the bottom.
I don't get why it's scrolling though. It should go into screen 0 at that point.
Yeah.
It won't be, because he's only changing the low bit offset.
Yeah, I'm only changing the low bit offset. So is this screen 1? Is this screen 0?
No, it's screen 1. Sorry, it's screen 1.
It's screen 1, but is it looking at screen 0 memory?
No, I'm sure it just loops round within that 16K.
Right, John, break it and run it again.
Yeah, right, what do you want me to do?
Run it again.
Go down, yeah?
Yeah.
So there's the 4 lines.
So that should be 60 times 8. What's 60 times 8?
$480.
See, I would expect that to appear back at the top.
No, I think it works within the 16K window, so you see what was at the top appearing at the bottom, scrolling in.
That's the impression. That's the impression that it gives, doesn't it? That it's not. Now that's because I haven't implemented the L thing. But it looks like it's right. Okay, let's go to the edge.
So it jumps there.
Let's go to the edge. Oh, I can't because I haven't implemented the full lot. Hang on. Let's implement the full lot. Right. So branch if not equal to bypass.
I've got that horrible sobering up feeling now. It's worse than being drunk.
Right. So this one branch. So this is decrement. Yeah. This one is going to be decrement H. And this one's going to be H again. Right. Right. Let's go across. Let's see how far we get with this. So this should not flip back because I've now done both bytes. Oh, look, it loops.
Yeah, I thought that makes sense because it's just an offset. It's like you know, like your horizontal scroll register on C64
Yeah.
goes from 0 to
0 to 7.
7 and then goes back to 0. But this is just a bigger version of it.
Yeah. So if we... oops, wrong window. So if we go down now...
Well, I'm just trying to work out why it loops round after that, because you've got an 8-bit vertical.
Well,
both
of them are 11 bits, yeah? It's 11
but you're only
bit
using
scroller.
8 for vertical, aren't you?
Yeah, if it keeps going down, it'll suddenly jump back to the top again.
Okay. Oh, hang on. There we go. I was on the wrong screen. So if I keep going down, it'll jump back to the top, yeah?
It'll suddenly do a jump back to the X symbol being at the top, I think.
I mean, 11 bits. What's that? 11 bits is 32768? That's an awful lot of bits. Well, how many scrolls is that?
Well, the thing is, if you've got 64 lines of 8 pixels high, you've only got 512 lines in your buffer, which you only need 9 bits to scroll through.
Yeah.
Or 10 bits. Yeah. Well, 9 bits, not to, yeah.
Yeah.
So I'm not sure what the point of having such a big vertical scroll register is.
Yeah.
It's possibly for when you... Because when you change the screen resolution, it doesn't change the resolution. It basically is a scaler on the screen. So if you go into a bigger scaler, so your characters are bigger, you've got more vertical height.
Your virtual height will be, if you go 4 times scale, yeah.
Yeah.
Makes sense, yes.
So, when... Oh, is this display H scale, display V scale?
Yeah, so it'll double times 4 times 8 to the screen. So it goes like 8 to column, 4 to column, 20 column, etc. But all it does is basically stretch the screen. But you have the same memory map for the screen. So it's always 256 characters wide in 4 bits per pixel mode anyway.
All right, let's do that.
Because if you're going to write a game, you're probably going to write it in 4 to column mode.
So the first thing we need to do is to change it. Right, let's constants. Have we got them in there? Descaler. That's these two, isn't it? 92A, yeah. Right.
Yeah, but when John writes Elite, you need split screen and high res in the bottom.
then you can use bitmap mode for that.
Right, so we're on 9. So
Elite the text adventure.
So you're saying if we do 1, that's just normal scaling, yeah?
Yeah, and if you do 2, it halves the resolution, doubles the size of the screen.
I'm going to say good night, chaps. I'm absolutely knackered.
All right, mate.
I'm absolutely pissed, but I'm saying. Lightweights.
Yeah,
Actually,
4 o'clock this morning was a long while ago.
No, mate.
All right, mate. Cherry bye, everybody.
See
Good
ya.
night.
You might at least look at what the values are, John, because I can't remember exactly what the values are.
Well, that didn't like that. Night, Gary. That didn't like that. I put 1 in there, and we get.
Yeah. What's the rest of that register though? Because there's it's only the bottom 2 bytes, the bottom 2 bits.
Now, John, you might not be writing to the right register. Because that depends on whether you've got DC select set to 0, which is, I can't remember where it is. It's the bits 1 to 6 on control.
Yeah.
They have to be 0 before you write to scale.
But I thought we was 0. Anyway.
What was the last thing you did when you changed it though?
Well, that's what I'm saying. I have in this.
Yeah, but the thing is, you don't know what the operating system set those middle bits to.
Yeah.
We're not changing them.
Right, let's put a macro in here that can change DC select, yeah? To the control, yeah? So that's all we need. And that's all we need, yeah? So in here, you're saying is that
if you're going to pass it a number, then you need to shift it left 1, and then, yeah, you need to read what's in the register, and it with 81 hex, and then or the number you send, but it needs shifting 1 to the left, so you've got to do that first. Because it's bits 1 to 6, not to 5.
So we are ending it with so like that, yeah? So that's 0. And then we need to hang on. So if it's 3 to the power 2, isn't it? So, well, no, we don't need that.
Because you're going to pass controllers not 1 or 63,
yeah,
I think it is.
Yeah.
It might be better to do it as a macro, John, and just do it as 0163.
Well, this is what I'm doing. I'm trying to create the macro. So we load the control, preserve the 2 bits, and then OR it with the I'm going to call that DC select, and then OR it with power. I've forgotten how power works.
Just do DC select greater than less than 2. Got 52 parts across.
DC select.
Well, only needs shift 1 bit, doesn't it?
Oh, well, 1 then.
Yeah.
So just do DC select.
Like that?
Hang on, what do I screen collect?
And another one.
Less than 1. Double less than.
Oh, so that's Boolean shifting, is it then?
Yes. Yeah, because it's a constant, not a variable, it'll work.
Right, okay. Okay, so don't need that. So we and it to preserve the top and bottom bits, yeah? And then shift over which one we want, so... And then store it back. Right, so... Then...
It doesn't protect you against putting stupid values in DC cell, but...
No, but, you know... So what do we put in DC cell? 0, like I've done there, yeah?
0 for what you're looking for. It needs to be 1 for some other registers.
Right,
1
okay.
for some other shifts, some to get versions and stuff.
Right, okay. So, okay, let's hit that then. So we should... So what's 1? I would have thought setting the scale to 1. Is that saying 1 pixel?
There's a table, mate. You let's look in the table.
Oh, is it at the bottom, is it? Hang on.
Yeah, somewhere.
That's the incrementer.
If you've got the right bits set anyway.
Oh, here we go. H scroll specifies the horizontal scroll offset. Yeah, okay. Base map, tile map. Hang on, so you guys can see what I'm looking at.
I can't find what you. I found tile stuff.
It's the scale variable you're looking for.
Let me do a find scale. 1, 2, 3, 4. Oh, here we go. DC H scale and DC V scale will set the fractional scaling factor of the active part of the screen. Setting this value to 128 will output 1 output pixel for every input pixel. Huh?
That's 1 to 1 then. So you want to set it to 64.
64 doubles 32 is 4 times. So 1 pixel in, 1 out. 64 is 1 in, 2 pixels out.
Right, okay.
Yeah.
For height.
I'm still not sure that...
No, once we've done it, well, no, that's done it, yeah.
So that should be 64.
Right.
And there we go.
Yeah.
You've done it.
40 character
Whoa,
mode.
whoa. You've used decimal. Come on, grow a pair. You're better than that, John. At least I like to think so.
Right, so... so 60...
That's better.
So 64 is 4 times.
No, 2 times.
2 times.
That's 80 column. That's 40 columns, sorry. So 128 is 1 to 1. Divided by 2 is 64. That's double. Divided by 32, that's 4 times.
That's
Because-
that's 2 times.
That's 2 times in one direction, but not the other.
Yeah, so if you're doing in both, that's 4 times, yeah?
No, it's 2 times horizontal, 2 times vertical.
Okay.
Yeah. You can do them individually.
Yeah. So we could
But then
simulate
you
a
get-
VIC-20.
So you can come to 64 shaped pixels.
Yeah, so we could do a VIC-20, which is...
Which way, 32? Or is it 20?
There we are. There's a VIC-20.
Right.
So the smaller the number, the larger the scale.
Yeah.
Yes, because it's a divisor.
So should we make some constants of those then?
Yes. Because I'll forget them in the morning. State I'm in.
Right. Okay. So what we so these are DC scale factors. Yeah. So DC scale.
X2, X4.
Yeah, X2 equals 4, 8, 16, 32.
I should point out that annoying noise is Jasmine, not me.
16, 32, 64. So, times 2 was 40. So
You might well
times...
put times 1 in there as well, because you might need to revert.
Good point. Will you be quiet?
So that's going to be 80, 40, 20, 10, 8, 4, 2. Does that sound about right?
Yep. And times 1 to 8 will be 1. And then you got very big pixels.
A very big pixel.
So if we
I'm sorry,
do...
it's my dog.
That's all right, mate. So if we do that
Quiet.
in there,
People are complaining about you.
that should be even bigger.
Don't like a dollar.
Don't dollar, it's dollar, yeah. There we go. Here we go. Right. So for
Now
the
scroll
Commodore
it.
screen would be set to that. Nice. And that would be the normal size. Cut that. Where?
She's licking my phone.
It sounds like Andy's stomach's rumbling. Right, okay. So that's...
So if you put it into 64 mode and then scroll, what happens?
Yeah, let's do that, shall we?
It should go twice as far and then wrap again. In theory, because the screen buffer stays the same size.
Yeah.
No matter what you scale her.
Right, here we go.
People are taking the piss out of you, so stop it. Yes.
So we'll still get the 4 rows at the bottom and then wrap, yeah? Which we do. And then...
Eventually. Yeah, there they are.
You've got to go a lot further to get wrapped around there.
Yeah.
It does a good job of scaling, actually, looking at that.
It does. It's quite impressive. If only you could scale sprites just as well, it would be great. With 2 minutes, guys, I'll be right back.
Yeah. Nice. So we've learnt about scaling. So we've done the scrolling. We've learnt about how to... That is clever.
Which is only provided we haven't set up any other
Oh,
interrupts.
yeah. And that would be the caveat. But that is very clever, isn't it? That.
Because I've seen it somewhere. Yeah, you can set up interrupts for sprite collision. You can set interrupts for line and VSync.
Yeah.
I'm not sure how the line works. Qbit 8, scan bit 8. I don't make any sense what they are.
Yeah, this documentation is not brilliant, is it? So, so what's this start and stop malarkey? start and stop determines the active part of the screen. The values here are specified in the native 640 before 80 data display space.
Is this like going into 38 column mode or something?
Oh no. So H start 0, H stop 640 will set the active area to the full resolution. Note that the lower 2 bits of DCH start and stop and the lower 1 bit isn't available. Is that right?
Yeah, horizontal multiples of 4, vertical multiples of 2. It means like your screen's 0 to 640, but you can move the left-hand edge and the right-hand edge in for like 38 column mode, but you've got more control.
Oh, I see.
That's the way I interpret it. It's display, not screen.
I see. So we can shrink the view portal then?
That's the impression I get from that, yeah.
Alright then, let's have a blast, shall we? Let's create another one.
Use same program to increment and decrement those instead of, yeah.
Yes, that's what I was thinking. So it says we need to be in 0 for it. No, 1. No, we need to be in 1. So we need to be in 1 for it. We'll turn off the scaling. Right, so right, so let's get rid of all this because it's all single byte anyway. Right, let's put the constants in because I don't think they're in there. No, DC start and DC end are not in there, are they? So, right. So, we'll put them in there, yeah? I hope everybody's learning. Because there'll be homework.
Oh yeah, I'm learning loads. Don't drink on a school night. That's the important one.
Right. You're just here for mental support. All right, mate. C64 and C128 programs can be X16 compatible. Yes, mate. When we get a fuller understanding of what the Vera can do, we're going to convert Myriad. We'll have to forego the sound effects, so we'll forego the sound effects, but we should be able to get Myriad working on the X16 pretty quickly. Once we understand the full capabilities of this Vera thingy. So that is the plan, is to get
C64 and 128 programs, though, they're not binary compatible.
Not binary compatible, no.
You can't load a C64 game because the sprite pointers and everything are completely different.
But we should be able to migrate it with a little bit of effort. To 9, to A, to B, to C. Oh, that's wrong. Oh, no, it ain't.
What's wrong?
No. I've just realised that they're using that DC select to reuse bytes for other things, aren't they?
Yep.
Yes.
So they can fit more registers in.
Yeah.
Because there's only, is it 16 registers or 16 addresses, but 28 registers or something?
Yeah.
So it's latched.
Right. Okay. So yeah, we're using Kick. Yeah. So once I've put this repo out there, this will use Kick. You'll have to load the workspace in, but you'll have to change that directory to where your emulator is. Yeah. But it should then work straight away with Kick and the Kick Assembler Studio. Just in case anybody wants to mess around with it. Right. So we've called these what by they are, even though we've replicated the same things, and I don't think that's a bad thing myself.
You've got constants with lowercase and underscores. That's disgraceful.
I copied yours.
Yeah, but the ones I'd used, I'd reformatted.
No, you left these as they were.
Yeah, 'cause I haven't
video,
used them yet.
DCH scale was left like that. So
Because I haven't used them yet. Well, the ones at the top were all in caps without underscores. My OCD's going ape shit right now.
oh dear. All right.
Ah, leave them. You're all right.
All right. Now
You-
look,
you
you're getting me
definitely your lowercase.
deleting stuff. Right. Underscore DC underscore to underscore big DC underscore.
Still underscores.
Yeah, so shut up. We'll mess around. Come on, we're just trying to get the constants file up.
No, just do it. Wait, take the piss.
Yeah, shut up.
It's not my fault. I didn't want to drink wine. Just found the bottle full of it.
Right. So we've got to set DC select to 1, which I have done. And so now we're going to change. So key up, we're going to do the vertical start. So DC underscore V start. Oh, how are we going to make it go down?
Just experiment with V start and H start for now, and then we'll have a look at V and H stop.
Okay. So
Just to get an understanding of what it's doing, see if it's doing what we think it's doing.
yeah. So up and down will increase and decrease V start, yeah?
Actually, John, up and down do H start, and left and right do V H stop. I know it doesn't make any sense, sort of, but it does.
Alright then. So up and down.
It's easier to see H start and stop.
Yeah. And left and right, we're going to do stop, yeah? Okay. Right. Let's see what damage we're going to do. Right, so up and down, H start. H start, wasn't it?
So that it doesn't reduce the width, it just shifts the image, the whole thing across.
Yeah, and so if we do the other way,
that does alter the width.
so you could actually simulate a Commodore 64 screen by doing this, and then you've got your border. All right, Mikroman.
Why do you want borders?
No,
Apart from
it's just
the opposite.
no. It's just the fact that we can do it.
It's weird that H start just moves the horizontal start position across, but H stop actually reduce. That makes sense, I suppose.
Yeah, so H start is saying we're not going to start the screen until this point, and H stop is we're going to stop the screen at this point.
Yeah, it does kind of make sense. I expect V will do the same thing. You'll shift the image down.
It'll, and then we'll end up with a border all the way around, won't we?
But it could make for some interesting effects and flying the screen around.
Yeah. Yeah. Because, I mean, you could have a game that's got a narrow field of view. So you wouldn't need
But
to...
you can also shake the whole screen.
Yeah, shaking. Yeah. Yeah, because you could just rotate round the numbers on the X and the start and stop values, give the impression of shaking. Right. So that's what the start... So that, I suppose that's where the border comes into it then, because then we could set that black area to be whatever colour we wanted.
Yeah, there's a byte for border colour, isn't there?
Yeah, yeah. It's just above the H start. Here.
Oh, yeah. You have to do that on DC select 0.
Yeah, so yeah.
There you go. Set the border colour on. Then change your border. Just any things, yeah.
Yeah. So you could simulate a 64 VIC-20, whatever. Or, like I say, if you had a game that was a narrow column like Ski Slope, for example, you wouldn't have to worry about the rest of the screen. You could just squish it up to the area that you want and just have that as your screen. But, yeah, blowing up, make the screen shake.
Lots of possibilities, yeah.
But it won't affect the row size, because the row size will always be 256.
Yeah, you're just adapting what you visually see.
Yeah. Not like the VIC-20, because when you narrowed the screen, it narrowed the row size, so you had to recalculate everything. Right, okay. What else? What else can we learn?
Tell you what you could try.
Yeah?
Try doing an STZ to store 0 in the accumulator. In Kick.
Store what?
STZ command, which is meant to store 0 into the accumulator. And I can't get it to work on the Kick.
You couldn't get it working on the Kick?
No. I do store STZ memory address, and that's 0 as a memory address. But STZ in its own is meant to set the accumulator to 0.
Oh.
At least that's my understanding. And I can't get it to work. And yet I've seen in example code people using it. Unless I'm talking out my arse. Which, that's quite common.
Right, let's get rid of all this then.
Just put it anyway. Put it as your first line of your code.
Yeah, I'm just making a different example, mate. So I'm getting rid of all the unnecessary code, yeah? Right, so you're saying FTZ.
ST stores Z.
Oh, STZ.
Yeah. No, S. Sierra Toilet Roll Zombie.
Yep, got that.
Yeah. So that on its own should store Z in the accumulator.
Yeah.
Right, but on my version of Kick, which I think is up to date, if you try and assemble that now, you'll get an error in line 33.
Okay. Here we go. Yeah.
But does it work? compile okay, or assemble okay for STZ and then memory address?
Yeah, that works fine. So if you do STZ variable, it'll write zero into that memory address. But my understanding is STZ on its own.
Yeah. Supports 0 page, X index, absolute X indexed.
You're supposed to be able to do ST space A as well. And that's supposed to work. Nice stack rats.
No, it's not liking that. It's erroring straight away.
But the other form of the command is ST like that you got there. But that doesn't work either under kick.
Right.
Now I thought that was a legitimate command, but it doesn't seem to work.
According to 65CO2 it is.
Yeah. I just wonder if, because that's a really useful command, because it saves the whole 2 bytes. 1 byte. 1 by 1 cycle. It's 656, yeah.
Right, hang on. I'm going to bookmark that. Well, according to that, there's only 4. According to this, there's absolute X, 0 page, and 0 page X. There's no.
Yeah.
There's no.
On 6502.org, it says it can also be used as STZ for storing it in A.
Yeah.
But interestingly, it doesn't give you the opcode for it.
Well, the .z is 0 page and .a is absolute, so we need hashtag.
Yeah, A is absolute. I mean, even if we force it to do that, right? Yeah, it's still not. It doesn't know it. But why is that so big? Really?
That's what she said.
But according to this website, right, which is the 65CO2, there's only 4 addressing modes for STZ.
Yeah.
But if you go to 6502.org, 65CO2 opcodes, it says,
STZ on its own stores 0 into A.
but it doesn't. What's interesting about that is it gives you the opcodes for the 4 normal options, but it doesn't give you the opcode for STZA.
But that guy that I posted the videos from on YouTube last week, his example code uses it.
And what does it what does it use for the opcode? Because if you look there, there's the opcodes 6474. Can't read, it's too blurry, my eyes don't work.
9C and 9E.
Yeah, then it says, also worth noting, a bit further down, STA can be replaced with an STZ and the TXA can then be deleted. And on the section below it, where you've got load A TXA, which results in a slight improvement and 1 fewer bytes and 2 fewer cycles. But it doesn't tell you what the opcode for STZA is.
I think that's wrong. I think they've misunderstood it.
If it's valid, why don't they tell you what the opcode is? Because it gives you the other 4 opcodes.
Yeah, I think these are the valid opcodes, and I think this is a mistake.
But I've seen it used in sample code. That's what confuses me.
Sample code that works.
Well, it's from a guy that seems to know what he's doing, so I assumed it did. But it was written in CC65, not kick. I'll look into it.
Oh, hang on. Whoa, hang on. No. Look, here, it's talking about this, yeah? He's saying that this STA can be changed to an STZ, which is right. That is a valid... That is a valid command.
But what's the TXA got to do?
And then you can get rid of the TXA because you're storing 0. X is 0, look.
Yes. Yes. All right. Yes. But that's got nothing to do with putting 0 into the A register.
No, because...
It doesn't seem to exist according to that.
No, because
Or
it
the
then
other way.
loops to
Right.
here. So A will always be 0, yeah? So that's what it's saying. You can put store 0, replace that with STZ, and that will work, and then you can get rid of that and save a byte. That's what it's saying, not the fact that you can...
It's confusing because he talks about the STZ before the TXA.
Yeah, yeah.
Yeah.
But do you understand?
Yes, I see what he means now.
But the code that I've seen, he uses STZ as an LDA #0.
Which doesn't seem to be valid based on either of these pages.
I know that's the problem.
Unless he's created a macro to do that.
I don't think he has because well, I'll have a look tomorrow, mate. I'll need to dig a laptop out and then go on handy.
Do you know who it was so we could search for it?
It's that guy, the other guy that does all those YouTube videos about Vera that I posted last week.
Oh, hang on.
It's his stuff.
Hang on, mate. Hang on. Because
I've also seen an article that says you can use STZ or STZ space A as interchangeable.
Are you on about this slithy mat?
Yes.
Let's see if I can...
It's stuff shit hot. I mean, it really is good stuff.
Right, I'm just searching. I downloaded the entire repo, so let me just see if this STZ is on it's on its own.
It's certainly one of his slides.
Yeah, but I'm looking at the code, mate.
Yeah, no.
Now,
I mean,
none of his
code is in the slide.
none of his code's got an STZ on its own. So you're saying it's in a slide. So which slide would it be?
One of the Vera ones. It's probably the Vera one.
Let's have a look. That's lesson 9. Oh, that's the slide. Hang on. Because I downloaded all. That's because I've been kikifying it, yeah. So I could release it for everybody. No, I don't want to go in there. I want to go in.
I've just done a quick search, can't find anything, but it's still a very useful instruction, that.
Oh, yeah.
Especially since you can index it with the X register.
Right, so it's 9. So let's have a look.
Look for one with code on it.
Yeah, that's one with code on it.
Next one.
No, he's put, look, Vera CTR. It's Vera CTRL.
I might have seen it somewhere else. I saw somewhere that said STZ and ST space A are interchangeable. They're the same command.
It might be an undocumented command.
Maybe.
Unless it's in his
Well,
transcript.
we've got a map of the instruction set anywhere, so we can see where it would fit.
Oh, there's no STZ on there.
Might be one of the very early slides when he's talking about assembly language and well, I didn't really watch them.
Right, okay. So let me move that over there. So the early slides is storing...
Or the sprites one. It could be the sprites one.
Say what?
The sprites slide.
The sprites one.
Yeah, because the sprite slide, the tiles one was the only ones I've really watched.
Multiply tiles, piano, mouse. Clock. Sprites. So 18, less than 18. Right, nothing in there. Right, code here. No. Oh, hang on. Right, so he's doing STZ Vera. STZ Vera. Right, so there's nothing in there. No, mate, I can't see anything.
I'll dig into it, mate. I'll find out what I found. Maybe it isn't. Maybe it was just a typo on one of the slides I've seen.
It possibly could be, mate. Possibly could be. I mean, if anybody wants to, it's there. That's it. If anybody wants to get his code, that's his Git repo. Yeah. That's what I've downloaded. I'm trying to kickify. Right, slight digression there.
Right. All the 65CO2 instruction reference I've found can only list those 4 addressing modes.
Yeah.
Which is annoying because it would be useful, but
yeah, it would be useful to have 1 byte just to say load the accumulator with 0, wouldn't it? Rather than 2 bytes, you know, load A with 0. But, hey, never mind. Unless there's a load Z. Is there a load Z?
No.
LDX, LDA, no.
No, there isn't.
Oh, that's stop.
Well, there's one undocumented instruction listed already.
Right, so what's this? Is FX position? Is that to do with the screen or sprites? Oh, let's go down here. So you're saying tiles is characters, yeah?
Yes, but tiles can be up to 64 by 64 pixels.
Tile height and tile width, but they're all 1 byte each.
How's that only 1 bit?
Yeah, when you said 64 by 64, but these are 1 bit. So there must be another address that says how big they are.
Oh, maybe the rate. Sorry, maybe the
I'm
rate
sure
by
I
8 or
saw
16 by
something
16.
about 8, 16 or 32. I'm sure I did.
Sprites are 8, 16, 32 or 64.
Yeah, but they're
Tiles
sprites.
might-
I'm on about character tiles.
Yeah, character tiles might be 8 or just 8 and 16.
That's probably what the tile height and width are, is double size, yeah?
Yeah.
Right. So the tile base address would be the base address of where your custom characters are.
Yes.
But is that the base address in the Vera memory or the base address?
Yes, Vera memory. All graphics, all sprites, all tiles are in Vera.
So the first thing that we would have to do is copy all that data into the Vera.
Correctamundo.
Yeah, height and width are 8 or 16.
Is there he likes Mikroman's playing. Mikroman's playing.
If you go to next page on there, it tells you about tiles.
Right. So sprite data can only go there. Is that what it's saying?
No,
No,
sprite data can go anywhere, but it has to be on a 128-bit boundary.
Right. 128-bit boundary. Okay.
I think so, because if you look at them, with the sprites and the tiles, you can only set the top so many bits, and it assumes that the lower bits are all 0.
Right.
Because you haven't got the register space for it.
Okay. Right, tiles. Tiles. Here we go, tile. $256 colour mode. Crikey.
Yeah, you probably want to stick to 16 colour mode, because they start eating RAM at that point.
So 16 colour mode is 2 bytes.
It's 2 pixels per byte.
Oh, 2 pixels per byte.
Yeah.
So the top nibble is the background colour, the bottom nibble is the foreground colour.
No, because there's no background colour. So the top nibble is the first pixel, the second nibble is the second pixel. I don't know why it says background and foreground colour. What are you looking at? Oh, so you're looking at...
Yeah, because it says here map base points to the tile map containing the tile entries, which are 2 bytes each. Each bit in the tile data specifies. Oh, each bit in the tile data specifies 1 pixel. If the bit is set, the foreground colour is specified in the map data. If the bit is set, whoever wrote this is worse than me.
Yeah, he's a techie guy. He's not very good.
If the bit is set, comma, the foreground colour as specified in the data map is used. Comma, we're missing a comma. Otherwise, the background colour as specified. If the bit is set, the foreground colour is specified. Otherwise, so if the bit is not set, then the background colour. Right. Oh, so no, I'm still confused.
No,
Why
you've
is it
got
two
map
why is
base,
it
which
two-
has... Sorry, John. If you look at map base, you've got character index, which is the character, then you've got a background and a foreground colour. No, that doesn't make sense, because
No,
your colour...
it doesn't make sense, mate.
It depends on what mode you're in.
But right. So it's saying for every byte of the character has a complementary colour byte with it. So for a typical character would be 8 bytes, yeah? So that basically means that each character for every row could have 8 different background colours and 8 different foreground colours.
No.
16. Because the first byte is the character.
No, there's 16 colours available, yeah? But on a character that's 8 bytes long, each of those bytes could have 2 colours out of the 16, yeah? That's how I'm reading this. That's how I'm reading this. That for every byte of the character, so we'd have 8 of them, there would be a complementary colour attribute byte that comes with it, determines for that byte what the foreground colour is and what the background colour is. So we'd end up with, for every character would have 16 bytes attached to it, 8 for the actual character, and then 8 to determine for each one of those rows what the foreground and background colours are.
No, the foreground and background colour are set by the second byte in the video memory. John, are you on that page? Scroll down to the bottom of that page. And there's a link to a page about tiles. Right at the bottom. Or are you on it already? I don't know what page you're on.
I'm on Vera. I'm on the Vera programming page.
I would strongly recommend watching that video on tiles, because it's a lot simpler than this was making it out to be.
Yeah, because this is not written very well.
Right,
Is it?
John, go there about halfway down the page.
Because that's this Tile Mode 1, 16 colour.
Keep going. It's about halfway down. It says this is the default mode, 1 bit per pixel. There.
This is default to start the X16. Character set is nothing more than 1 bit per pixel, which is the Commodore 64 and VIC-20 thing, yeah?
Yeah.
The tile being 1 character of PEXSCII 8x8. Now, 1 character of PEXSCII 8x8 is 8 bytes.
Correct. So each tile is 8 bytes, with every pixel defining whether it's foreground or background. Your foreground or background colour is the second byte in your video memory, where you have character and then colour, which is foreground and background colour.
But this is the offset, right? So it's saying that byte 0 has only got 8 bits in it. So how are we going to get an 8-byte character?
No, that's map data. That's your video map screen memory, yeah? Offset 0, tile character index, character 0, character 1.
So this, right, okay.
And then the next byte is background colour, foreground colour.
Which is what we're doing already, yeah?
Yes.
Right, so it's nothing related to the actual character definition. This is the memory on the screen.
Yeah, so if that's a 0, it uses tile 0.
Yeah. Right, I get that now.
It changes when you switch different, colour modes, because like 256 colour mode, you don't have background. I think background colour is preset for all the screen.
Yeah.
And you change the foreground colour of your
the tile.
Character tile.
Right, I get that now. That it's talking about the
It makes a bit
screen,
more
not the
sense than
character
that other
definition.
page, doesn't it?
Yeah, I get it's talking about the screen and not the character definition. Because that was the thing. It was, are they talking about this character definition? No.
Yeah, and if you scroll up a bit, it tells you 1 bit per pixel. It's 8x8, 8 bytes for a character.
Yeah, so 2K memory.
But if you want 16 by 16 characters, pixels, it's 32 bytes per tile. And
right.
The Vera will automatically, you say character 1, it'll automatically step in 32 byte increments.
Yeah.
Etc.
So,
depending on the bit per pixel mode and the tile size.
Yeah. So the next. So have we got time to do it now? I was just wondering whether we could take the myriad data character set and see if we could upload it into the Vera and use it. That's what I was thinking. That's what I was trying
Pixel
to
data, yes, easily. Shouldn't be difficult.
No, so we should be able to do it, say now. Yeah?
Yeah, it's just a character set. You're not bothered about... Because core information's separate.
Yes.
So it's exactly the same. 256 tiles, text 2K, which is exactly the same as C64. So all we've got to do is load the
myriad
C64 character set, shove it into memory somewhere on the Vera, and then point its tile base at that.
Yes.
Sort of thing.
So
and you have a new character set.
Let's try it. Let's see if we can...
Sounds easy when you say it like that.
Yeah. Let's see if we can do it. Right. So, so the
biggest problem is knowing where to put it in memory, because we're not sure where anything is.
No, but...
Stick it in 0, because nothing seems to be using 0.
Stick it in 0.
Can we just, I need to download this emulator, and just wondering if we peek what's in the tile base address, we can see where the current one is.
So let's go back to the base address, which would be 2F2E. Okay. Print. Whoops. Oh, I didn't know that happened in the browser. Okay. Print. Tile 2F2E. Oh, 9F2E, sorry. 2F. What am I looking at? 2E. Oh, map base address.
Tile base 9F36.
9F36? Oh, for L1. Ah, 36 then.
And then ignore the bottom 2 bits, and so you've only got a 6-bit.
248.
So take the bottom, what's that in here? Take the bottom bits off, and that's actually...
Well, the two bottom bits are not set anyway. The two bottom bits are not set anyway.
No, because they're 8 by 8.
So times that by 4 and just print the hex value of it. No, times it by 2, sorry.
Oh, did I scroll it the wrong way?
Probably.
Is that scrolling there? Bit shift?
It's shitty Windows, mate. I've got no idea.
Ugh.
Yeah, you have to do shift and then...
Other way, mate.
And it's other way. Shift 1.
Bit shift.
248, left shift.
Logical
1.
bit shift. Here we go. Right.
Yeah, no, you're right. Logical shift, other way. But logical shift and then a 1.
Oh, we have to put a 1 in it.
Tell it how many to shift.
Right. 2. Because it's 2 bits, isn't it?
Yeah.
62. So 62 is bits.
No, you pushed it the wrong way.
No, he's masked off the other. No,
I've
that's
masked off the 2 bits.
11, isn't it?
Yeah. So 62 is the thing, and it represents bits 11 to 16, isn't it? So then we have to bit shift that 11. So that's 1F, all the zeros.
That probably makes sense, actually, doesn't it?
Hang on,
that's where
screen
the
is at
current
1B,
tarmac
yeah? Screen is at 1B. So yeah, that would make sense, wouldn't it? 16k?
No, because 16k would be... Hold on, 1B. Yeah, that's be right. B, C, D, and E would be screen. F would be... That's where character set is. It's a sensible number.
That, to me, sounds familiar. For the wrong reasons.
Right, hold on, John. We'll try something here.
Now, are we saying that if we uploaded the character set to 1F0000, would that be overwriting this the
Override
wrong one?
existing, yes.
Right, let me get
Now,
the...
is the character set PETSCII or is it ASCII?
PETSCII.
Right, so character 0 is A, or is 1A?
No, character 0 should be @.
Yep.
Right, okay. So if you VPoke 1F000 with 255, it should change the top part of an @ to a solid line?
You can't do that. You have to do a VPoke 1, comma, F000,
Right.
comma.
I don't know how VPoke works.
Yeah, the top part you poke is a separate parameter.
So VPoke... Right, okay, so let me...
Just put an @ on the screen first.
Yeah, I'm going to
John.
put an @ on the screen. There we go. Oh, Jesus.
Oh,
Right, so VPoke 1, comma, F000, yeah? Comma... Is that what we were talking about?
Yeah, then comma the value you want to poke into it.
Yeah, so VPoke
Try
1...
it.
Right, VPoke 1, FFF with 255.
Yeah, try it.
Oh, we got a line. We got a line.
So, which confirms the character map that we're currently using is there.
Yeah. There we go, I'm blanking it out.
Reprogrammable graphics.
Look at
Oh,
this.
that's taking me back to the old Exodus Sorcerer days.
Oh, one more. There we go. That's it. We've blanked out the @ sign. Right, so we should be able to upload the Myriad.
You've got your Commodore X16 now.
Yeah, let me just find the Myriad. Here we go, Myriad. Right, so the graphics are going to look a bit silly because it uses the extended character set. Yeah, the 128 and all that were the same, wasn't it? So, right, let me just grab the character set. 64 character set. Grab that. Put that into the Commander X16. Hello world. We'll put that in there. Paste. Right, so we've got... This is the Myriad character set. So let's get rid of all the... Right, let's get rid of all the blanks. There we go. Right, so that'll be character 1, character 0 to character 1, character 2, character 3. That'll be enough. We'll only load part of this in. That'll be enough. Right. So, what example am I on? 11. Right. So we need to So I'm going to do import.
Just need to read them all in and show them in one FOO onwards.
Yeah. So myriad character set. Oh, you little sod. Oh, come on. Myriad. There we go. So, char set. Put a point there. Right, so I'm only going to load 256 characters because I don't want to mess around with... so I'm going to load 256 bytes, yeah? Which will be 64 characters? No. 256 divided by 8. 16, is it?
No, 8, 16, 32.
32. Oh, that was close. Right. Now, we need to set up our address, don't we? So, let's go back to these here. So, we're going to use 0. So, we're going to use data 0. I'm in the wrong one. Go away. Go away. Go away. Go away. And we're going to set that to F. And, okay, so once we've done that, then we can do our loop. Right. LDY #0. Looper. LDA. Char set, comma 1.
$0.
Say what?
You tell him, Andy.
$0. Put in hex.
Store in Vera
That's better.
data.
Do it like a pro.
Store in 0 data, and then INY. Branch if not equal to looper.
That's it.
That's it, isn't it? That's it. So, we'll do the clear screen. So,
Character set.
yeah, we'll do the clear screen. Right, so that, okay, so if I run that, that should load the first 32 characters, yeah?
Yep. So all your alphabet characters will change.
There we go. Right. A. @ B. C. D. E. F. G. H.
Game over.
I. J. K.
Should do this in
Look at
C64
that.
screen
Look at
resolution.
that. Hey, look at that. We've got the character set in. Myriad, here we come.
That'll look better in 40 character mode.
Yep. Okay. Let's do that. Hang on.
No, I'm just...
No. It was only that one instruction, wasn't it? This one.
Yep. Well, them 4.
Well, yeah. Right. Oh. Why are you not liking... There, isn't
Have you
it?
included your macros?
DC uppercase.
Oh, yeah, DC.
changed
Yes,
them.
we changed it.
So
Hang on.
constant should be all uppercase in my opinion, but who am I to say?
I totally agree. And no underscores, but there we go.
Shut up.
No, I'm a bit on the fence on the underscores.
I just say underscores.
Right. So,
But definitely, constants in uppercase makes it easier when you come back to it later.
Exactly.
Look at that, bullets and bombs.
look at that. Look at that. Now, the bad guys look a bit funny because they're in multicolour mode. But we've got it all in. We got it in, so it's just a case of tweaking those bad guy graphics to take them out of multicolour mode. Unless...
Which you're effectively in... Oh, and what's multicolour mode? 16 colours?
No, multicolour mode means you can each character can have 4 colours, yeah?
Yeah, you'd have to do 2 bits per pixel.
Yeah, we'd have to do a bit of a conversion on the character set to make them look a bit more realistic. But as a first go, without modifying it, I reckon we could get Myriad up and running. We've got the basic, except for the noises, yeah, except for the sound effects. We've got the basics of Myriad. We now know how to load the character setting. We now know how to manipulate the data on the screen. I didn't realise game and over was different sizes.
Where's the E for game as well?
It's the same one as in over.
But it's a different size text.
Yeah. I didn't realise that.
Oh, I never noticed.
No, I didn't.
Sure, the E would stand out very bizarrely, but
It probably did.
well,
Oh dear. How cool is that? Right. So that was rather surprisingly easy to get that in there.
Yeah, it's probably a bit more work to put that character set somewhere else and change the... Not much, you just need to change the pointers, just need to work out where they are. Well,
Yeah,
we know
but
what
it's
the
the
address
game
is.
though, isn't it? Once we're running in there. Hey, good Heemstad, welcome.
Yes, but within a game, you may want more than one character set.
Yeah, but I know Myriad doesn't have more than one character set.
There's more games than Myriad out there.
Oh yeah, I know, but I'm saying for Myriad, there's only the one character set. I understand what you're saying about the 2 character set, like with Aston Eats. That uses 2 characters.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Who's just subbed?
Frozen Welded.
Hey, Frozen welcome in.
With an underscore. The whole world's against me.
Well, thank you for the resub. 3 months. Nice. Welcome. He's secretly been subbing. Right, okay, so what else? What else do we need to understand the basics to get Myriad off the ground?
Ooh. Sorry, I'm just reading and finding interesting things.
Well, technically, we could get Myriad off the ground pretty easy, couldn't we?
Colour palettes.
Colour palettes.
I'm just looking at the tiles. When it comes to using them, you can... I mean, it's obviously it happens with sprites. You can flip the sprites and reverse them. You can do the same thing with tiles, upside down and back to front.
Really?
Yep, there you go. V flip and H flip. In other mode, not in 1 bit per pixel mode, but in other modes.
All right.
So you can turn your characters upside down and back to front in the screen memory.
So if, let's say if you had Galaxians and you've got all your character set all pointing up, you could get them to be rotated.
And come down. Or on Myriad, where you've got the ones that shoot up, I wanted Myriad, that was in Beep Sprite. Yeah.
Also, John, can I just point one thing out that's very important? It's Galaxian, not Galaxians. Common mistake, but it is singular.
But there's lots of them on screen.
There are lots of Galaxian on screen, yes. The game is actually called Galaxian, not Galaxians.
Unless it's some rip-off version.
Oh, rip-off versions don't count.
No. But yeah, we're in Myriad. No, not Myriad, the other one, the Beep thing.
Yeah, Beep Spriter. Beepcadia, yeah.
Arcadia. You've got ones that's moved across to the right, and you reverse them, you just reverse the character.
Yeah.
Flip it goes to the left. Instead of having two characters for left and right, you just change the bit there.
Yeah.
You can only flip them, you can't rotate. You can't do like a 45-degree rotation.
No, you can't. No, I thought with a combination of these two you'd be able to do it, but you won't.
No, you can't.
No, you can go left, right, up and down sort of thing, which you've got 4 directions you can move stuff in.
Yeah. Mission Impossible 3 is using software to flip the sprites. Yeah. Okay, so what? Mikroman put IRQ. I'm not too sure.
The IRQs work exactly the same as on the C64. Even the same register, FF and FFFE for the pointer. Works exactly the same.
Oh, right, so you can override the FF.
Yeah. Or you can tag it into the standard OS interrupt. But the thing is, if you do that, you've then got issues with the kernel being able to grab bits of 0 page.
Yeah.
Get rid of the kernel. Give us full control. Bare metal running.
You can't actually page it out or anything, but you can just kill all its access to the hardware. Take the interrupts away. It can't do shit.
So the IRQ would be the same as what we do now, yeah?
Yes. Yep. Except you can push X and Y. So you don't need to save your variables by transferring to X.
Oh, the new instructions.
Yep. So you can save yourself a whole world of pain.
Oh yeah, PLX, PLY, and PHX and P8. Yeah, they're the new instructions, aren't
they? Yeah.
So, hang on. If we overwrite FFFF and FFE,
yeah.
Do we have to take the ROMs out?
No, you can't take the ROMs out.
So how do we override that at those 2 bytes?
Because they're not in ROM.
Oh, they've made sure that they're not in ROM.
Yeah.
Oh, that was kind of them, wasn't it?
Ever impressive.
Well, they never were in ROM, were they?
Yeah.
I don't exactly know how it works, but I was on the forums the other day chatting to some guy who's been doing some work on it. But you can't patch out or you can't swap out the ROM at the top of memory unless you do it to a cartridge.
Right.
So there's no RAM underneath it because there's no lines on the VIA to patch in. Because I wanted to patch in extra RAM at the top of memory, and you just can't do it.
So you can't have a flat 64K.
No, that top whatever it is, 24K, whatever it is. You basically it's dead. It's dead weight. So you've got an 8K page below that you can basically page in and out of your high memory from 64,000 upwards to half a meg. in 8K chunks, but you can only page in 8K at a time.
So that paging would over paging instead of the ROMs, yeah?
So the ROMs sit at 4200 and something, and I think your RAM page that pages in and out is at C000. Don't quote me on that. But that 8K there at the top 8K of RAM, you can basically page that in and out of the top RAM. I've got a diagram.
Oh, so you're saying the banked RAM is from A1000 to C1000?
That's the one.
Yeah.
But the C1000 to FFF is the ROM and stays there unless you plug a cartridge in.
Yeah, you can't do shit. You can't do shit over there. It's just there.
Yeah, but you could put the RAM cartridge in.
You could put a RAM cartridge in, but you'd have to. Every user would have to have that RAM cartridge. It's an add-on. You can do that, but
the last 2 bytes.
Is it a good connector or does it wobble?
It'll wobble.
But the last 2 bytes of this FF is RAM rather than ROM.
Well, it's a control register, so there's a few control registers at the top end that you can dick about with.
Okay.
It's in ROM, but it's really not in ROM. So effectively, you've got from 2000 hex upwards to that ROM with the varying registers in the middle.
Yeah, because they've got the I/O at 9F treble 0, haven't they?
Yeah.
So it's basically from 0 to 9EFF that we've got used for memory, yeah?
Yeah. There's more than just Vera in there, but yeah.
Yeah.
And then your bank page of 8K. And then it's addressed 0 in 0 page.
Yeah.
Specifies what bank of RAM you're using. And 01
is the ROM cartridge.
Is the ROM mapping.
Yeah.
But you can't use that variable to map to RAM for the ROM. It's a different set of lines on the BIA or the processor or the magic board. I don't know what it's called, but that's basically how it works.
So you can't use them first 2 bytes in 0 page for anything. They are hard coded.
Well, you can as long as you're not paging RAM in and out. And if you're not using the ROM, you can use them because.
Well, yeah, I suppose you could put numbers in there. It's just don't expect things to be where you know.
Yeah.
If you go up in top addresses, you might find things that are wrong.
Yeah, you want to avoid using them if possible.
So, hey Warlock, welcome. Hope you got your coffee, mate, because this is brain aching stuff.
No, this is good stuff. It's sensible. It all makes sense so far.
So the one I'll pay more.
Yeah. So, in terms of understanding what the screen does, and now we've figured out how to load a character set in, we've effectively got the basic understanding to do Myriad, yeah? Except for the music, except for the sound effects.
Yes.
I don't profess to know about sound. Really, I don't.
You need to get tips in. He's brilliant at it. He's done loads of stuff for the X16 as well.
No, I know that, mate. But the Myriad sounds are procedural sounds, yeah.
Right.
It's not like Nico's Run and Astonites and Bianchetti that were all, well, not so much Bianchetti, but they were used by Goat. The Goat Tracker was the source of the sound effects, yeah. So if it had been Goat Tracker for the source sound effects, then yeah, I would have asked Crispy if there's anything he could do for us, yeah? But because it's all procedural, we have to figure out how to make it work.
Does it have to be procedural? I don't know if there's any tools, any trackers available, that's all. Because music's something I know jack shit about.
Yeah, I don't know much about it, mate. Well, I mean, all that'll happen is in the code, when I do the X16 directive, all the sound would be empty, so it wouldn't be doing any of the sound until we figure out how to do it, and then we could pull it in, yeah?
I mean, it's all AY stuff, and I don't have the first clue.
So it's not like pumping in this number gives you that note.
I have no idea, mate.
Now,
it depends. If you use the Yamaha chip, sort of, yes.
Right. Well, I mean, that Smithy fella did a sound bit, didn't he?
I've not got to that yet, mate. I avoid sound 'cause I don't understand it. It's just noise to me.
Well, I just make fart noises, mate, so it's... There was a tracker Chris was using, but I think it outputs VGM only. Oh, okay. Because there's the YM chip seems to look like it's got 8 voices, 8 channels anyway.
Yeah, you can sort of just tell it to make a noise.
Yeah,
and knowing it will just make a fart noise. But
well,
yeah,
this is what the
Vera's also got a programmable sound generator in it, and I can't get my head around how that works.
Well, it's here, look. Initialize the state of the VM chip. Silence all channels by setting the release part of the ADSL envelope to max. Then setting all channels to released. So it's just a case as if we can replicate what the SID does on this. It's just a case of different numbers in different bytes, isn't it?
Yeah. But you can, think SID like with the YM chip.
Yeah. Because then we could use the C64 SID procedural noises that we made and try and replicate them. Well, it's just trying to learn how to do it so we can do the procedural bit.
I think you get something graphical on screen and then we can patch sound in.
Yeah.
One step.
I think in the next stream we know enough now to get dangerous, and let's see if we can try and convert Myriad onto the onto the X16. Because all it means is all the pokes will have to change into the Vera system. Because when we went on Myriad, when we poke the character, then we poke the colour directly after it, so that will work. The thing is, we'd have to poke the background colour in as well. So whatever colour we're poking, we'd have to OR it with the background colour as well to make it black. And change the keyboard control, because that would be using the direct CIA control. So we'd have to make it do the charring. But other than that, I think we'd be able to do it. We'd have to change the screen layout, of course. That's if we wanted to use the entire screen, or we could just put it into 40 column mode and only change the offset. Yeah. Right then. I've got the. I'm really pleased we got the character set in there. I'm really pleased we got the character set in there. Right. I think we've got a lot done today. Yeah. We've understood a lot. Yeah. I've run out of things to do. I don't want to start sprites now because we'd have to work it out.
Yeah, sprites gets quite involved.
Yeah. Let's see if we can get a game. Let's see if we can get a proper game going. Maybe without sound, but at least if we can get a proper game going. So I will this weekend I will carve out Myriad to do for the X16 and let's see if we can get that working on the next stream. I'm sorry, Warlock, I'm about to leave. I'm sorry, mate. I know you've just popped in to proudly announce that you've been with us for 3 streams on the bounce, mate. He was late, yeah. Well, I'm gonna tomorrow. I'm gonna put this into Git. I'm gonna make sure I do it. I will let you know in the Commander X16 when I've put it into the repo into Git, so you can grab it, and then you can have a play yourself. And I'm sure Andy would want to change the constants.
I'll do it when I'm really, really drunk.
Yeah. Have you sobered up now, mate?
Unfortunately, yes.
All right then, guys. Well, thank you very much for sticking around.
Before you go,
yeah.
Have you actually ordered your board yet?
No, mate.
No? Good God. Why not?
There are other things that I need to buy first before I can.
Yeah, but it's only 300 quid. That's like less than a month's subs.
If you bought the keyboard and everything else, it was a lot more than that, mate, in one go.
Yeah, but you don't need to buy the keyboard and stuff. All you need is the board.
But don't you have to buy the chips as well?
No. It comes with 512 meg, which is what the Generation 2 will ship with as it isn't upgradable. So they make some memories only for developers if you need that extra memory. So you get the board with 512 meg of RAM on it, everything to go. You don't get the fancy keyboard. You don't get the shitty mouse that's really rubbish. You don't get the 2 meg upgrade that you don't need. I only bought it because I'm an idiot. And you don't need a case or anything. It runs with a standard 88 power supply. It'll fit in any PC case. Job done. It's all you need, the basic board.
I'll think about it.
Old PC, think about it.
I'll think about it. There are other things that I need to do, like 20 grand for a new conservatory roof, like something like that. Yeah.
Hey, Zapper, Warlock, I've got a Zapper charger as well. They're really good.
So yeah, I'll think about it.
Just sell a kidney.
But there's only 2, mate. There's only 2. Anyway,
you need 1.
All right then, guys. I will see you on the next stream. Yeah.
All right, guys.
All right. Take care.
See ya. Bye.
Bye.
No.
I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.